Alright, today I'm going to take us through the rest of Unit 8, which is the activity series, okay? And what I'm going to refer to is this sheet right here, which you may or may not have gotten in class. If you have it, go ahead and take it out. If not, you can get it from the important information section of eChalk, or just kind of listen and you'll get one in the next class. One of those three options. Okay, what the activity series does, okay, you can see there's a list of all of these elements. And notice it's broken up into metals on one side and halogens on the other. So if I come back to the PowerPoint here, whoops, what the activity series does is, there we go. First, if we define the term ability, or activity rather, activity is the ability of an element to react. Okay, so the easier that it reacts, the higher the activity. And then again, you've got your activity series, which lists them according to activity. Now, for little technical issues here, there's two types. You have activity for metals, just like I was trying to talk about there, and you also have activity for nonmetals. Now, for metals, the greater the activity, the easier it is to lose electrons, because remember, metals want to give away those electrons to form cations so that they end up with 8 valence electrons, which makes them happy. Now, nonmetals are going to be the flip side. They're going to gain electrons. They're going to form anions for the same purpose, to gain 8 valence electrons and to make them happy. So if I come back to the activity series for a second, here you have the most reactive metals. Okay, lithium, rubidium, potassium, all group 1s. They want to give their electrons away and be done with it. And then you have the least active. Okay, you have silver, platinum, and gold, which we refer to as the noble metals because they don't react very often. Okay, that's part of what makes silver, gold, and platinum so valuable, so that they don't react with anything around them. You also have an activity list of the halogens, where again up top you have the most active, which is fluorine because it's the most electronegative, the least active, which is iodine, which is on the bottom. Okay, so if we come back over here, you've got your activity series. Oops, let me get rid of my little drawings here. Is used to predict whether single replacement reactions will occur or not. And if the reaction will occur or not, you're either looking for a metal replacing a metal or hydrogen. That's one option. Or you're looking for a halogen replacing a halogen. So we're dealing with single replacements. Again, most active is on the top. It can replace anything below it, but not anything above it. Now I realize that sounds totally foreign, so let me give you some samples and we'll try to see if we can figure it out. Okay, why would you have to have the activity series? You're trying to figure out, will the following reactions occur? Alright, the first reaction is between zinc and hydrogen. You're trying to figure out, will zinc kick the hydrogen out and form hydrogen gas? Okay, so let's come to the activity series. Well, here is zinc, and here is hydrogen. Now again, if it's above it, it will replace it. And it gives you a little bit of detail out here. It says replacing hydrogen will react with steam and acids will replace hydrogen. So because zinc is above hydrogen, the answer to this one is yes. It will happen. Okay, meaning that in the real world, would it typically occur? Now on the flip side, if we picked anything below hydrogen, if it was, will copper kick out hydrogen, the answer would be no, because it's less reactive. And hopefully lab really helps make sense of this. Okay, the next one is, will cadmium replace lead? Okay, because will a metal replace a metal? So if we come back to our series, well here's cadmium, and here's lead. Okay, cadmium is above lead, so it can replace anything down below it. So the answer to this one is yes as well. And last but not least, we have copper and hydrochloric acid. So will copper kick out the hydrogen? I actually just gave this as an example. Copper is right here, and it is below the hydrogen, so it cannot kick out the hydrogen. And just as a reminder, you will not have to memorize the activity series. It will always be given to you. You just have to know how to use it. Okay, so if we come back up here, the answer to this one is no. So if you put copper and hydrochloric acid, nothing's going to happen. No bubbles, you'd get no reaction. And again, we'll